Let's continue. Next one is another matrix problem, spiral matrix. My dishwasher is running, so I apologize for that. It's gonna continue to run for 3 hours. Okay, let's start the timer. M by N matrix, return all elements in spiral order. Okay. M N. All numbers are between minus and plus 100. Okay, let's see if we can do this one quicker than the last one. Okay, M N. We can first just define M N. So M is the number of rows, matrix length. Okay, so matrix is a list of lists. So this will give us the number of rows, and this will give us the number of columns. Result will be a list of integers. Alright, so how do we loop this? Okay. Okay, so let's use I and J to denote row and column. So I and J both start from 0. Well, length of results is smaller than m times n, because the final result will have exactly m times n elements. So we want to first go to the first row and increment column. So first I is 0, and we increment j until we reach the end, and then we keep the same j and increment I until we reach the end. Then we keep the same I and decrement j, and then we keep j and decrement I until the second to the last one. Okay, let's try to write that. Let's see. Okay, we are going to for I, so I will be the same I. For j in range, j is gonna go from 0 to the number of column minus 1. That will be n, because n is exclusive, so this will go until n minus 1. Okay, so I 0, j goes from 0 to n minus 1. Result append matrix I j. Okay, so there we have the first row, and now we want to keep the same j. Okay, j is at n minus 1, and now we do for I in range. So I is gonna go from 0 to m minus 1. Result append matrix IJ. And now for j in range. So j is now go from n-1 to 0. So this is exclusive, so it has to go to -1, and it's gonna decrement, so that's gotta be -1. So result append matrix ij. And now last one is for I in range I-1 0, because it actually doesn't wanna go to 0, it just wants to go to 1. -1 result append matrix ij. And now we have done one round of 4. Now the next one, we are here, we're standing right here, we have just done 9 and 5, and what do we do right now? For j should start at 1 and I should start at 1. So while we're doing this, the next round, j should start at 1, not 0. We need some kind of helper variable that acts as a buffer, or should we call it a buffer? That just denotes that next time we are starting from here and we're ending from here. Okay, what do we call it? Okay, I do not have any good name right now. Let's just call it buffer. I guess buffer also starts at 0. So it needs to start from 1 now. Buffer. Increment buffer to 1. Okay, so now it starts from 1 and it doesn't go to n anymore. It needs to be n minus buffer. Okay. It would be nice to have an even bigger example. Okay, but we know the idea, so buffer goes to n minus buffer minus 1 append. And here then, I is gonna go from so after the first row we actually need to increment I, because we've already appended 4 and now we just want to start with 8, so we cannot start from 0 again, then it will be duplicated. So let's decrement I. So now I goes from except this is still gonna start from 0. So what we need is for I to just I goes from can we do something like 1 plus buffer m minus buffer. Okay, so first round buffer is 0, so it goes from 0 to n minus 1, and then I goes from 1 to n minus 1, which is correct. Okay. And j would go from n minus 1. Okay, so after this we got 1, 2, 3, 4, 8, 12, so it does not start from n minus 1, rather it should start from n minus 2. And then the next round it should be even lower. Okay, so it will go from n minus 2, that is there, minus buffer, and they will go all the way to 0. It will go all the way to 0. Next time it will go all the way to 1. Okay, so that should be what we need. And then okay, let's finish this, and then I have to consider, because this is still using the I, and I wanna, this I needs to change. Okay, this will not work, but let's just finish the last part first. So last part would be 1, 2, 3. Last part would be m minus 1 for I in, okay, this is last part, so I'm minus 1 minus buffer there should be minus 2 as well, and it's gonna go until 1. Okay, so it is still not sufficient, because so for this, well, after we do this, I is 0, and now we're doing for I in range that, and we need that j. So what is j after all of this? It should be at n minus buffer minus 1. Let's see if that works, because right now I'm suspecting that we need something else as well. Let's just check first. Okay, so this one worked. Now, okay, so the spiral is going well, but we have one extra element. because this, while we are inside here, it doesn't really stop when we have reached the full length we need. It seems tedious to add an extra line after all of these. 6, 7, then 6 again. Can't really think of a way to not add that, so let's write it out first and then think about how possibly we could improve. So if length is what we want, then we can return result. So I mean, I think this is what we need, but it does look repetitive. So oh, what am I doing here? Well, it's been a long work day. Okay. So it works, but it does not seem to be that fast. Let's try one more time. No. Okay. I can't seem to think of a way to not write that. Alright, let's do time and space complexity first, then I will spend a few minutes to think about this. So we are traversing like this and appending the result, then we simply do one traversal to cover all the elements, and we are not doing any more work than that. So this is linear time and linear space. So that's easy. Alright, let's try 2 minutes to think about how we could potentially refactor this or come up with something smarter. Since right now we have to check after each for loop. Well, I guess we don't need to check the last one because it's gonna be checked here. Not fast. Oh wait, what? So now it seems to be really fast? Okay. Okay, I guess then that's fine. Alright, let's look at some other solutions. I'm so glad this video is gonna be a little shorter because all of them are 1 hour long or more. Wow, one liner. Let's see. We have some God solution here. Take the first row plus the spiral order of the rotated remaining matrix. Oh wow. Huh. Very smart indeed. Okay. Wow, very smart. I do not know how people come up with this, but this is very amazing indeed. Let's see if there are some more normal solutions. This is more like what I'm doing. Traverse right, traverse down, traverse left, traverse up. Okay. Okay. So I guess one thing we could probably refactor is so before this we have already checked that it hasn't reached all elements yet. I guess we could check again here before we do this. And then we check again here. So it's the same logic, but it's gonna just save us some lines of code. Okay. Yeah, pretty much same results. Python 3. Oh, this actually looks like mine. 4. Seems like they're not using any buffer. they are just incrementing and decrementing the row and column indices instead. Okay. Okay. So in that case, my solution is actually a bit shorter. Okay. Okay. I think I am good with this problem. So call it night. I mean, it's 9 p.m. So let's stop here. Let me know if you have any questions. I will see you in the next problem.